Our next session is going to be about multilingual content security and its challenges. I hope all of you are ready. We will be joined by Mr. Kuan Eeik Tan, who joined Huawei as the head of Europe Cloud Competence Center in 2016. He has been building up the R&D Center for Consumer Cloud Service in Helsinki. He and his teams focus on creating AI-driven technology for online safety, privacy preservation solution, visual search and voice search in Petal Search, Petal Maps, and Huawei mobile services. During this time, he has also successfully established collaborations with universities, including joint labs in Europe. Kuan is a technology leader with over 20 years of professional experience, specializing in cybersecurity, cloud computing, big data, and AI. Prior to joining Huawei, he has a long history with F-Secure, where he held multiple key roles and led many key initiatives, delivering secure and scalable content cloud solutions to operators globally. Ladies and gentlemen, presenting to all of you, Mr. Kuan.
Yes, thank you very much, Fatima, for the nice introductions. Good afternoon, and just give me a sec. Okay. Good afternoon, and also good morning, ladies and gentlemen. So my name is Kuan Eeik Tan. You can just call me KE. I'm the head of the Europe Cloud R&D. So today, let me share my screens. Right. So today I'm going to go through talk about the challenges in the multilingual abuse detections in the context of content security, and to walk you through to give you a bit more in the background, our Huawei mobile services has been growing rapidly over the couple of over the past few years. So globally today we already have more than 730 million users. As you can see, the cloud services that we have offers varies from essentially it's an application distribution store, videos dealing with short videos, long videos, musics, books, Petal Search that dealing with open source data, maps, and also assistant dealing with newsfeed. So you can sort of imagine the amount of content that we are dealing with that are coming to our ecosystems. That are that it has been also growing significantly. So the question is how do we ensure our users in our ecosystems are able to access to good quality contents, and also free from the content that are harming them. And how we sort of ensure the parents that when their children are sort of being user in the Huawei mobile services, they feel safe and secure. And so this lead to the missions of our teams, where our team is basically focused on creating protecting the online safety of the Huawei mobile user globally, and also especially in Europe. And we're also constantly looking to how we could create a privacy preserving solutions in the area of search, maps, and also the webs. So our team basically we have more than 40 researchers, and mainly are PhDs, and we also collaborate with top universities in Europe. And we focus on these 5 different areas, from the content security, privacy protections, visual search, voices, as well as image processing that is related to the maps. And my talk today will focus on the first sections, which essentially is the multilingual abuse detections. Yeah. So a word of warnings. So the following slide may contain some improper content, just to give you some ideas on what sort of the content that we are dealing with. So in a nutshell, our goal is basically to build auto sort of moderations systems, and this that we have to also deal with the sort of data from mainly generated by the users, such as comments, discussions, forums, and also maybe some open or public sort of domain in the context of webs search as well as actually some professionals like contents like the books and readers. But most of the problem actually that we see challenge is really coming from the user generated like contents. So to put it actually in the technical terms, like what essentially we want to do when we talk about automatic moderation, essentially that like we're sort of building actually a system that could actually like classify actually these multilingual sort of like text. And our goal is to be able to sort of like reduce actually the unsure actually portions. And this is the part actually that will involve like manual actually moderations by the actually like moderator. And we would like to sort of like maximize actually the shrill regions, which essentially could be like normal or could be sort of like abusive. And through actually this step, like we will also would like to like address actually the false negative and also the false positive. And we try to like understand whether like this actually like wrong classifications is it like due to actually the annotations like errors, as in like something to do with the guides, something to do with the annotations, or some basic like problems in the samples itself, or essentially it is actually a machine learning problem, which could be like a wrong classification. Why actually there are wrong classifications on that, and there are also a set of like data that are disputable in nature, where actually even human itself like we could not actually reach actually a consensus like on that, right? So, and this is actually the high levels of like overview of our sort of like pipelines actually looking at where we have a sort of like a pipeline actually for to train actually the sort of like classifiers with actually the data augmentation and also like quality assessors like data quality assessors modules and the classifier itself. And this is basically the model which actually we will basically use like on online. Yeah, and there's basically a feedbacks loop into here to basically like for us to retrospectively look at it to sort of improve that. And actually, what are the sort of like research challenge actually that we have to deal with, right? Like when it comes to like this. Firstly, actually, there's really like lacking of sort of like standards of like guidelines, and without actually a consistent sort of like guidelines, like even not really talking about within the company, but we can also see that there are different sort of definition across different companies, even actually across actually in the sort of like academic like industry. So we can see there are many open sort of like public data set where actually that the guideline, the definitions of what is actually like offensive and like discriminations and so forth or hate speech are also slightly actually like varies, and this actually will also cause like noise when it comes to the annotations. And another area actually is about anonymization, which is actually important that we since actually the data that we are dealing with are sort of like abusive in nature. Therefore, like we want to make sure actually whatever we process do not actually like able to identify the individual. So anonymization is also the one of the very first step actually that we are sort of like doing. And then the nature of the abusive detection is a very interesting area, because unlike the normal typical NLP problems, the amount of post samples that we are getting could be like 100 to even 1,000, more than 1,000 times more difficult to sort of acquire, because this essentially is not really a common problem. So, and this problem is essentially is like finding actually a needle in the haystacks, right? So therefore actually like we have to like look into how we can address actually the low resource, because like as we know actually the deep learnings like model essentially are sort of like data hungry. Another aspect is about the quality and culture, and where the culture that, because we are dealing with like user generated data essentially a lot of like informal and a lot of like these backgrounds, like even we talk about the same group, but depends on where actually upbringing of an individual, it will also affect actually the dialect, the way he express things, and it could be also explicit, implicit, disputable like in natures. So therefore, like we need to actually design like what's sort of like a quality assessment method to ultimately actually identify like this problem, so that actually we can like tackle them like separately. Right? And it's also important actually that like to ensure that like we could actually build a consistent, a generalized model that actually could perform consistently across like different like domains. And moving into the model itself, that a lot of model today are really based on formal languages, including, for example, BERT and so forth. It's mainly trained with Wikipedia and also the books. And there's really lacking actually the language model that could really handle the dialects and informals, as in the everyday sort of languages. As also pointed out by previous speakers, that language people will be able to would usually user actually would be able want to speak actually freely, express actually their thoughts actually freely when it comes to this kind of user generated contents. And there's also looking into we believe there's no one size fit all solutions. Therefore, actually, that is also important to look into the assembles of classifier. How can we combine different classifier of different diversity to sort of improve the overall classifications. And sort of last actually and not least is basically about trustworthiness, especially that it is important to really also defense against the evasions attack, to be able to sort of explain actually the reasoning actually behind, and ensure there's no bias and and also fairness in the decisions itself. All these actually that this aspect actually is very important in sort of creating a robust and trustworthy sort of abuse detection systems. Yeah. So I will sort of deep dive into each of the areas to give you more ideas about those challenges and how do we sort of address. So as pointed out actually in this paper by itself, it's called garbage in, garbage out. So it actually highlight a lot of challenges in terms of the sort of in guidelines and also the annotators problems actually that even there's difference between annotator of professionals crowdsourcing all sort of things. Yeah. And essentially, what we found that based on our experience, it's important to really establish a common sort of language for all the teams, and even actually in the industries and so forth. And the second thing is about actually that they are also overlapping in different sort of classified categories. This will also add confusions from the moderator perspective. And there's also inconsistent notation due to different interpretation of an annotation guide, and which essentially also due to the cultural difference is also to some extent subject to the bias and dispute. And there's also variations when it comes to the comment discussion, which we often actually see in the comments area and the search, as well as the book publication, as I mentioned earlier on. So essentially, it boils down to some of the guidelines essentially that how actually we actually resolve this is basically that we need to try to actually work on the guideline, bring in some examples, and also improve the understandability and also trainings of the moderations of the moderator. And this is just some of the example where sort of how we have separated out the modeling actually process and indicating what actually the model should be actually capable of sort of detecting. And we come to the moderation process that could be sort of different sort of area, and how we would how actually the model actually could help the moderator to sort of make actually the decisions. And certainly actually there it's also important to give example of what actually works and what is considered a no, and also the certainty level to sort of help to understand the confidence levels in the annotations. Now, the very first thing actually that we have been also looking at is the anonymizations, and this basically the parameter review, which essentially based on the non-entity recognitions, where we sort of explore various sort of models, and then once actually we're able to sort of detect actually the entity, and then the masking model actually will come into place, which will also leverage actually on the knowledge base to sort of perform the masking, which could be sort of redact, as in removing the things, or hashing actually that entities, or we may actually generalize actually the entity, or even replace, and we actually have the you can sort of allow actually the user to sort of decide configure replacement based on the utilities of matrix, to maintain actually the trade-off between actually pseudonymization and also the utility aspect. And this is actually like some of the like example that we have, can see actually that kind of multilingual here is like, for example, the countries and date. So it can be sort of like changed in different forms. This is from the first phase of the NER, and and this part is the second phase on the like PDR like itself. Now, so the model itself that like is also based on the CRF, and the latest model that we have done is basically combination of the BERT actually with the CRF, whereby the last layer is a CRF, and this is actually some of the like the result actually that we have achieved at the entity level and also like sentence like levels. So a lot of actually times like at the standardizer, this will be actually sufficient for most of the use case, because that is important to actually bring actually alert, so that actually the moderator actually can actually look at it and perform the necessary anonymizations. And we are also like compare actually with the state of the art, and probably here what is worth actually looking at like is on the Kaggle data set, which is not seen by all these three models, basic, procedural, and also our models. And some of our model basically like perform like well actually in the area of like precision and also like that the F1. Now, looking into the next is about the how do we then address actually the low resource problems like quality and cultural like issues. And as I mentioned before, the nature of the data that we are facing is essentially a low resource, which is in the range of like 100 times or even 1,000 times actually less compared to normal sort of like data. So therefore, we're looking at what is actually the best way, and also what is the cost-effective way to basically build actually the classifier actually with this good actually performance. So, and we sort of like explore like the kind of naturally the all shot with the natural data. This actually will perform the best. However, it actually means that like it is going to be very expensive to scale up to like 70 plus or even 100 like languages. The cost actually will be data acquisition cost actually will be like highs on that. Those in this case, this will be ideal like case. And the second one is like we sort of like trade off with the sort of like machine translated. And then we will also compensate, in some extent, actually will compensate with the human corrected data on those suspicious and those positive samples. We'll compensate it with the human actually corrected. So this actually gives us a good trade-off, because in general we notice actually that like the translation will actually like may actually increase the model performance up to like 10% when it's basically like translated actually like properly. I'll talk about the problem in translation a bit more later. And then moving to the zero shot like itself, but this is sort of but this sort of good in general. It sort of like can sort of like ramp up actually the result actually like quickly. Sorry about this part. It doesn't actually need actually translation like in this particular case. And then there's also the English like classifier, where actually then because English classifier is the best classifiers because it has a lot of resource. And here we will be looking at how we can just like translate actually the test samples to the English. But this is also have a penalty in terms of like cultural preservation and code mixing, and also it's sort of like slower like from the system performance perspective, because any sample actually will require translation. And lastly, we also look into the data augmentations. And this data augmentation is actually a very good way to sort of like jumpstart to improve the performance in low resource like settings. But ideally, actually, the performance is actually poorer than the first two approach. So therefore, actually, when we look at it, like the first two approach is more sort of like sustainable. And this is actually a chart actually that are comparing the all shot and also the English like the zero shot like approach on that. And for example, when it comes to data augmentations, like where we need to have some data actually to start off. Therefore, actually, we've been looking at how we can generate like this data like syntactically, and looking into like different sort of like methods on this part. So from the replacement to like sentence like levels, to like generative like GPT-2 and also like PPLMs like on that, right? So the goal actually for this is to actually have some sufficient of like data actually for us to like sort of like to jumpstart. For example, that we kind of realized that like 600 like policy samples is what actually we require to sort of like jumpstart to have some like reasonable sort of like the performance. But in order to like improve the performance, we need actually more than that. Yeah. And so this is actually some of the result where actually we have explored like this kind of 8 techniques, like from the add copy, like EDA, PDBs. And also we also iterate like how does this like different augmentation techniques will impact like in the different like classifiers itself. And in general, actually that we found it like add and copies basically like perform actually like quite well in the context of but as a classifier itself. And there's also like more details which you can find in the ENLP like 2020 here. There's a paper that we have published jointly with the university, and you can get more like details like from there. Now, looking into the data quality itself, one of the problems when we start actually using the translations. The translator actually today are mainly actually trained with these like public and formal sort of languages like the opposed like the data sets. So actually, that what we found that like a lot of change, it actually changed actually the classes like from positive become the negative of the actually original like natural things. It is because of there's actually translation errors and some keywords sort of like drops, and there's actually like no sort of like dialogue itself. Like for example, actually there like this actually like chickens here actually it has been like sort of like wrongly actually like translated into some like abusive like sort of like word like in Arabics, and some of the words are also sort of like being sort of like drops, or there are also some like wrong translations on that. And this is actually therefore like in some of the like important like languages and how we've compensated is basically that to sort of like shortlist like those sort of like false positive like and false negative samples to be and also all the positive samples actually to be corrected actually by human to sort of like compensate like that. And you can see actually that the improvement is range, the average is about like 10% actually gain like by just having a human like corrected on the translation itself versus actually a pure machine translations. And then moving next is a kind of like the challenge actually in the annotations, like despite this actually the guide due to actually the upbringing like differences, the cultural differences, and some actually annotators tend to be more strict actually in the negative than others. So this is example on like out of the 5 annotators, like how many and 3 are like stating like sort of offensive, whereas the other 2 are sort of like okay. It also depends on the context, like whether like it may be okay is like when you're actually talking actually in the application context, where compared to whether like someone is actually mocking against actually a persons or countries or companies and so forth, right? So therefore, actually, that like we have to look into internal data analysis is one of the important areas, and we also need to identify the outliers, like and train actually the annotators, like so that they understand what it means actually in this guide. It's not just like throwing them the guide and expect them actually that to be able to like annotate actually flawlessly. It doesn't actually happen like that. And also we will also like identify suspicious sample or send for annotation, as well as like increase action annotation. But this certainly actually have we sort of like look into comparing if we increase number of annotator versus certainty levels, like what sort of like trade-off, which actually could give us like more better like result or confidence about the annotations. And this is one of the example actually that when we perform the inter-annotator agreement analysis, like using, for example, like some like substation like Kuan Eeik Tan like score, we sort of like wanted actually to know actually firstly like what is actually the upper limit of the performance when we talk about the human. So essentially human is the kind of upper limit like on that. And then how actually the model actually can work, whether the model actually has reached the upper limit of the like human actually like performance or not. And the other thing is also that like for example in this case we notice it kind of has really reached, but then the question is then okay, what is really why is actually this gap? So this actually promises look into deeper into like whether like there's certain annotator actually behave differently, and then this actually will trigger a discussion or training with the annotators. and some of the sort of annotation will have to be redone or sort of like being dropped actually like completely, like in this particular case for annotator like 87s, like on that, right? And another problem is actually that we can see when we come to about is about like how do we actually build a model which is robust and generalizable. And when we solve generalizable, that means that no doubt actually that when a model is put in a different domain, it may drop. But we sort of as we want actually to ensure that actually the performance like drops is like it's not significant. It's so that it can perform like consistently. Here, therefore, like it's important to look into like to really identify what is really the like difficult data set, as in like these are essentially more disputable like in nature, and also like how the model actually is good in kind of like seeing the distribution. Like for example, actually that for those in the like red colors, like these are like storm fronts. That itself actually that like when you go to training and iterations, the performance is really like quite bad. Same goes to Davidson and Fountain. So this actually gives us some idea actually that the nature of the data itself is quite disputable when we actually open up the content and then do a deep dive actually on that. Whereas actually like some of the like data itself, like for example this Twitter and the WhatsApps here, in general they perform actually quite well, like on that. But the moment is basically also like being used as a sort of like a test data set itself, whereby as if like simulating actually this is a new domain that we're first seeing, we can see actually a performance drop from that. So this basically tells actually that the model itself, there's a problem in generalizing actually in like some actually like new domains, right? And this actually will then prompt us into looking into like performing out of the domain like data analysis on that. So we explore like many different ways to sort of like visualizing it and also like measuring to quantify how do we actually quantify that there's indeed out of the net domains like with different approach, right? And the red one actually essentially is the evaluation and blue is the trainings, right? And here we can see actually that like in the domain ones, they are massive actually overlapping between the evaluation and the trainings in the embedding like space. So these are visualizations of the embedding like space. And the domain two is, you can see that there's a small overlaps. So therefore we can see actually that when we have actually enough sort of like coverage, we can see the performance of the model actually increase like significantly, right? And we also realize actually this is actually tend to be more associated to like FP, the false positive. But when it comes to the false negative, it's not necessarily so because it tends to be like overlapping like very often between actually the evaluation and the training. So the false negative is more deeper into that. It's more like abstract in the sense that like maybe it's lacking of like context. Maybe it's lacking of like dispute. It's to some extent it's in the borderline of like disputability. And also some of the very like missing some like context, or you need to actually rely on some external context to sort of like explain stuff like that. So the FN part actually the problem is more like difficult actually like on that. And this is one of the example that we can see kind of like false negative. For example, when it comes to like a lot of abusive content may not necessarily be explicit, but they may be sort of implicit, where if you just purely look at the text, it may be perfectly okay at the face value. But in order to really like know this, like human is very good because it really like require a deeper understanding, like the context and also the culture, as well as actually the common like sense. Even the counts of the culture part like, is also tricky because like we also notice actually different people from different country, right? For them it's okay, but it's not okay in another sort of like country or user of particular regions, right? So there are a lot of like this complexity in the like cultural sort of like aspect. This example, I never had a smart conversation with a person of your like genders. Like these humans we can interpret easily, but not really actually for the this like model itself. Therefore, actually we sort of like argue basically actually that like today actually we are still actually at a very infant state of the NLU. Is purely actually more of the data-driven approach in terms like building actually the like good model like kind of transformers that actually like lead us to thinking actually that there is some intelligence, but in reality, when we actually open up, it is actually not. And And these actually like more examples of like of the kind of implicit things where we really do have to understand what is really the target actually that the target that is actually referring to, and how actually what is actually the trigger, the expressions, and how is actually the expression actually relate actually to this kind of like target. And if you also look at like some of the false positive example, like in this case, like here the word that which is just a female dogs, but this is not really like well understood, like and also like and this example is also the same, that at a glance like human actually will be able to interpret like this because we have common sense, but it's not really the case like for this but right. And there's also problems actually on like some language specific like culture things, like where like just for example in Arabic, and I'm sure also in many other languages, where a word actually can carry like many sort of like meanings. Like for example, like in this particular case, when it's being used in the case of economics, then is okay. But actually, if you use in the context of politics and refer to a sort of like a spice actually like on that. Yeah. And there are also many more sort of like cultural or day quality actually related things, but I don't think I have time to sort of like cover that. So I'm just, therefore, actually, I'd like to give you some idea on how do we sort of like addressing actually some of the complexity actually like on that. For example, actually that in Arabic itself, actually Arabic is a very unique case because it's more like a language family. It's like, so we can actually look into like a modern like standard Arabic versus actually the dialect, which could be varied by regions. And user may use Latin, and it tends to be more like having a lot of typo when you actually use it in online, right? And you can see this example, for example, there are like more than 22 Arabic dialect, and it could be written in different form like completely on that. And this is actually how we can sort of expand the direct coverage by through the Arabic data like augmentations to expand to like different sort of like areas actually on that. And we also like increase the vocabulary of the sort of like bird, so that actually that like it will be able to detect actually this kind of like offensive or like contents like properly like through the vocabulary expansions. And this is actually some of the result actually that we see if you just like using actually the bird itself versus actually using the data augmentation and vocabulary expansion. It can increase like up to sort of like the 10 points, even actually without a separate sort of like keywords like classifiers actually on that. However, there's actually a limitations in terms of like how do we actually scale up all different dialects, and also obfuscations like mixings, and also the emoji problems actually in Arabic, right? So this promise to like extending it with a tagging approach, where like sort of like the where actually like certain sort of like sort of like keywords are sort of being tagged with a sure or unsure, or maybe same go with the emojis, right? It's itself, right? And this basically actually helps to sort of like improve actually the robustness of the like but actually that in actually like detecting actually this kind of offensive like contents actually on that, right? And last part actually that we will sort of like move towards actually the high performance, like is also important to do that. And one of the challenge that we have promised to look into is about the active learning. And this why she is doing this, because like essentially that firstly the problem itself is like finding a needle in a haystack, right? So we need to be able to like, we cannot just rely on like just connotations, because that would be very inefficient. Therefore, we need to look into how we can even like learn like incrementally, and also without actually with the minimum set of like label like data. So this promise to look into the active learnings like on that. So it's a very economical like way to actually like make actually the machine learning actually like solution like deployable in that. So, and over here basically that we have also like sort of like look into how we could monitor actually that the progress of this active learning, and then like identify actually what should be actually the limit that we are finding. So firstly, actually we look into how actually the sort of like the negative samples and like placenta are sort of like being actually ultimately sort of like discovered actually through these active learning like systems actually on that. You can see that in general that like post samples are sort of like being discovered like sort of like upfront. And we also monitor actually the cross validations like result, like score, like AUC, to see how it progressed. As you can see, actually, that like at the beginning itself, that like when we test on a different like data set like UBTC and TCC, these are public data set, that we can see that it's almost already reaching the peak at the beginning without even going through the entire like things. So in a nutshell, basically what we have actually noticed that like the itinerary is very effective way that we can actually cut down actually the sort of like the amount of data that is required to reach the optimum performance easily by 3 to like 5 times like from that. As you can see, show actually in this particular like area. And the other area actually that we're looking at is like, as I mentioned earlier on, there's no like one model actually will fit all. There's no a silver bullet for that. But what actually we observe, like even from the competition itself, like Sam Involves 2020, all the kind of like top winnings of like model essentially are assembled like sort of like model. And we've been also like looking and exploring in this area how we can sort of like explore like different methods and way to build a like ensemble model from like multi-seed approach, like bagging approach, data shuffling, like also heterogeneous like mixture, like by mixing different type of like sort of like assembles for that. And the result actually we've also seen that like in any sort of like assembles itself, this example of bagging assemble, but this actually picture also apply in general for all other assemble that assemble generally like perform like way better than actually the average and even the best model itself on that. And as in summary for the assemble is basically that like it basically improve like all the performance and they are similarly sort of like effective on that. And the most drastic is really like found by just fusing actually the 3 models. After 10 models, it's just marginal gains. And one important aspect to highlight about the diversity, the more diverse actually the assemble model, the more actually effective it is. And even we look at the distillations because we want to make it deployable in the productions. Distillation is an important process to make it deployable, and the performance actually like drops is actually like acceptable. Like there's only a slight drops when we compare to the assembles of like models like itself. And assemble typically give about 5% actually like gains compared to the kind of best model, right? So moving forward, like when we come to like this abuse
Mr.
detection.
Kuan,
Yes.
I'm sorry to interrupt, but we are way over time already.
Yeah, I'm actually wrapping up. Yeah, so
okay.
This is my last slide. Yeah. So by moving actually like so what we actually look at a multilingual abuse detection is really not really a classification problem, but I think the future forward we are actually we are treating it as an NLU a problem where it's important to be able to explain actually the decision behind. Like for example, at first glance, like this this sentence, those that are above 65 so are not qualified. They may seem to be discriminative. However, if you can sort of like explain that like it's because there's actually certain rule in certain country has sort of like forced that, and this is no longer sort of like discriminations, and it also depends on who actually has actually like stated that, whether actually it's actually a trusted source or whether actually is quoting it. So therefore, actually it's important to sort of like understand what is really the expressions and what is really the target and who the source of like saying it, and also the reasoning actually behind. So and this is actually the emphasis that we are saying actually that the abusive like detection should actually move towards detection in order to create a robust and trustworthy sort of abuse detection systems. And this is some example of our research impact to our research community, and also and lastly and basically we are like hiring also in different like Huawei like data research centers across actually the globe. And you're sort of welcome to sort of join us and collaborate with us. Yeah, thank you very much.
Thank you, Mr. Tan. That was really a lovely talk. So because of the lack of time, I'll just have one question. And that is that in annotations where you have some cultural differences and there is divergent views from the annotators itself, can we do a majority voting or even averaging of the labels so as to get the annotations correct, or is there a better way for it?
There is actually a better way for it because even the majority itself, right, is also to some extent also disputable. So essentially the best way is actually to separate into a full in agreement versus actually majority in agreements. So that actually when you know full agreement, that actually the theoretical limit for machine actually could be like 100%. Whereas actually the disputable, then we have to break down into further, because disputable due to like different quality things, it may be due to like some wrong classifications. However, it may be also like due to like lacking the context, implicit, or requiring some external. So the problem over there is more complex that we need to like dissect it like further. So therefore, I would actually advise to use a divide and conquer strategy, break down the problems and break down the data set. Because when you're dealing with like millions of data set, it's really like difficult to really go through one by one. It's not scalable. And also different methodology to identify each of the like problems.
Thank you very much. Andres?
Thank you, Mr. Kuan, and thank you for your talk on multilingual content security and its challenges here at VLD 21. We appreciate you taking the time, sir.
Thank you.